Hi, this is Math 1340, and this video is over chapter 4.4. We are going to look at solving exponential equations. And a couple important properties here is if you are raising a value to a power, and then you're raising another value, the same value to a different power, well, in order for those two to be equal, the two powers have to be equal. Okay, so you can't raise the same number to two different powers and get a different number. It just doesn't work that way. And the same thing with logs. If you have the same base, you can't take the log of two different numbers and get the same number unless the two numbers are equal. And it almost seems fundamental in a way, as simple as 4 equals 4, even if 4 is written in a different form. Right? But we can use those two facts to solve a lot of these. So 5 to the 2x minus 5 equals 125. We can rewrite this as 5 to the 2x minus 5 equals 5 to the third. And then 2x minus 5 then has to equal 3 for this to be true. And so then we add 5 to both sides, you get 2x equals 8. Divided by 2, you get x. Next one, 16 to the x equals 32. We can adjust 2 to the 4 and just 32, so it's 2 to the 5. And this is just when you raise a power to a power, you're just multiplying those. So 2 to the 4x equals 2 to the 5. 4x has to equal 5, so x has to equal 4/5. Oh, I'm sorry, 5/4, which is 1.25. With this next one, you get e to raise to the 0.05t equals 1500. We take the natural log of both sides. Get the natural log of e to the 0.05t is equal to the natural log of 1500. The property we had before is this power is going to come down. So you have 0.05t natural log of e equals natural log of 1500. Natural log of e is just 1. So you have 0.05t equals natural log of 1500. So divide by the 0.05. We can plug this in a calculator. Natural log 1500 divided by 0.05. You get 146.3. So 5 to the x plus 2 equals 3 to the negative x. We can take the log of both sides. And that brings down that power. We have x plus 2 log 5 equals a negative x log 3. Now the key is to get the x's on the same side so we can factor them out. So we'll distribute the log 5. So we get x log 5 plus 2 log 5 equals a negative x log 3. We'll move the negative x log 3 to the other side. X log 5 plus x log 3. And move the 2 log 5 to the right side, so we get negative 2 log 5. Now we can factor out an x. So x times log 5 plus log 3 equals negative 2 log 5. And then divide. X is negative 2 log 5 plus log 3. And we can put that in. Negative 2 log 5. This number divided by log 5 plus log make sure parentheses here, plus log 3. We get negative 1.19. Okay. Sometimes we can solve these if we rewrite them in exponential form. So here log 4 of x, base 4 of x is negative 2. So we can rewrite that as 4 to negative 2 equals x. Okay. This happens, the best way to do it when x is what you're taking the log of. And so x is equal to 1 over 4 squared, which is 1 over 16. Log x plus log x minus 3 equals 1. Right. They have the same base 10. So we can put this together first. So since they're adding, we get log base 10 of x times x minus 3 equals 1. And then we can write this as 10 to the first equals x times x minus 3. And now what we can do is distribute, and you're going to get a quadratic, so we'll get everything off to one side. So 10 is x squared minus 3x. So 0 is x squared minus 3x minus 10. Then this factors into x. So minus 5 x plus 2. X minus 5 equals 0, gives you x equals 5. X minus plus 2 equals 0, gives you x equals negative 2. This is one where you do have to be careful. Before we haven't really had anything like this because we had exponential forms for the previous ones. And then the last log form was just a straight log, so it wasn't a problem. This one, we have multiple logs here. So we have to make sure these values work. The 5 isn't a problem. Log 5 plus log 2 isn't going to be a problem there. Both are positive numbers in those logs. The negative 2, though, that's going to give you a log negative 2 here and a log negative 5, where you can't have a negative with a log. So the x minus equals negative 2 is not a solution. Right, similar here, we'll do log, put these together, log base 7 of 2x plus 7 over x minus 4 equals 1. So 7 to the first equals 2x plus 7 over x minus 4. Multiply the x minus 4 over, you get 7 times x minus 4 is 2x plus 7. Distribute. And then we'll subtract the 2 over and add the 28 to the other side. So we get 5x equals 35. So x equals 7. Then again here, check it, make sure it works. 2 times 7 plus 7 is 21. And 7 minus 4 is 3. You can check to make sure the answer works out as well, but checking to make sure they come out positive is one of the main steps. That is the answer. Here we have multiple natural logs. Natural log of 4x plus 10 minus natural log of x plus 7 equals natural log of x. The main way I would do this is to combine everything together. You have natural log of 4x plus 10 minus natural log of 7 plus x minus natural log of x is 0. And then since the two that are negative, they're going to end up in the denominator. So you have the natural log 4x plus 10 over x and over x plus 7. And that's going to be equal to 0. Right, so our base here is e, our is 0. It's going to equal 4x plus 10 over x times x plus 7. Now, e to the 0 is just 1. That's just equal to 1. So we can now solve this. I'll multiply the x times x plus 7 off to the other side. So I get x times x plus 7. Distribute, so I get x squared plus 7x. Subtract the 4x and the 10, so I get 0 is x squared plus 3x minus 10. So 0 equals x plus 5, x minus 2. So we get x equaling -5 or x equals 2. Then we gotta check again. X equals -5, we can see with natural log of x, that's not a solution. With 2, you get 2, you get 9, you get 18. Those are fine, so this is the only solution. Right. Now, when these can get really tough, best way to do it is graphing. So here we have e to the 0.4x. Let's put that in. Second e 0.4x and minus 3.7. And what you can do is you can actually make this so it's a little easier. You can either set each side equal to y1 and y2 and find the intersection, or what I want to do is I'm going to subtract the 4.5x and then minus 9.1, so it's equal to 0. That means I'm going to be looking at something on the x-axis, which is going to make it easier to find the point. Minus, oh, that's not minus 9, minus 0.5x minus 9.1. I could have combined the 3.7 and the minus 9.1. Doesn't matter since I'm just typing it in anyways. All right. So this gives me one graph. Hit graph it. Let's do zoom standard. Right. We can see that we crossed once and we're going to cross again. We got to get that into our window. So let's move the x max to 20. It doesn't matter that it goes off the graph as long as we have the 2 points here. So we can do second calc 0. And we just have to go left bound. Enter. Right bound. Enter. Enter again. There we get a negative 2.77, y equals 0. Right. So that's the first, well, we don't need the y equals 0. We've made that on purpose. The negative 2.7 is the first answer there. The other one now, second calc 0. We gotta go all the way to the next side. Yeah, find it somewhere. It's somewhere here. There we go. Right, so left of it, enter. Right of it, enter. Enter again. You get 10.18. We don't have any natural logs or logs, so both of those answers are going to be correct. All right, then we can do the next one. Yeah. I'm going to do the same thing. I'm going to subtract the 3 over. Now, we got to put these in a special way. We got to do log x divided by log 6. That's just to get the first log of base 6 in. Then we do plus log x plus 3. That divides by log 6. That's to get the second term in. Then we got to subtract 3. Again, we're going to look for the 0 here. So we'll do zoom standard. So I'm putting in log x divided by log 6. That gives that term. I know I didn't put parentheses inside. We don't need them, but I'm just specifying that. Plus log x plus 3 over log 6. That gives me that term, and then minus 3. It's all set equals 0. All right, so we see it's going across 0. We need to probably adjust the window here. Let's try 20. All right, so it does cross. I'm going to still adjust the window some. This to be maybe 5. This to be 5. Maybe we can see it better. A little bit better. All right, so let's do second calc 0. So left of it is enter. We gotta go right of it. We want to make sure we cross it over, so you want to make sure your y is positive. We go enter, yes. It says 13.27. X is equal to 13.27. It's a positive value, so in either of these cases it works out. So that is your solution. Right, in the next section we'll do some applications with logs and exponentials. I'll see you then.